Hello everyone, this is Seema Patidar, Assistant Professor EC Department from Oriental Institute of Science and Technology. Uh, the subject is electronic measurement and instrumentation, in which we will discuss measurement and error. First of all, introduction and definition. An electronic instrument is the one which is based on electronic or electrical principle for its measurement function. The measurement of any electronic or electrical quantity or variable is termed as the electronic measurement. That means any measurement of the measurement of any electronic or electrical quantity, for example, voltage, current, frequency, and temperature. If we talk about the physical quantities, that pressure, temperature, distance, these are all the measurement quantity. Or if we are talking about the electronic measurement, then for electronic measurement, voltage, current, these are the electronic measurement. Now, in measurement, the important thing is accuracy. If we are measuring an quantity, how accurate is this quantity? So accuracy can be defined as accuracy is the degree of closeness with which the instrument reading approaches the true value of the quantity to be measured. It indicates the ability of instrument to indicate the true value of the quantity. For example, accuracy. Degree of closeness with the instrument reading approaches the true value. True value means if you are measuring a voltage which is 5 volt, and if it is giving 4.9999 volt, that means it is accurate. And if it gives 5 volt exactly, then your measuring instrument is 100% accurate. It is the 100% accuracy. Next, precision. It is the measure of consistency or repeatability of measurements. It denotes the closeness with which individual measurements are departed or distributed about the average of number of measured values. So the difference between accuracy and precision is very clear. In case of precision, we consider consistency or repeatability. That means, for example, a quantity voltage or current, say current, we are measuring, and for the same instrument we are getting the same output current. For the same input we are getting the output, for example 10 volt output we are getting. And for the repeatable measurements or consistency repeating measurements, for the same input conditions, for the same circuit, if we are getting the same output, that means our output is precised, or we can say the measuring instrument is precision, having precision. It denotes the closeness with which individual measurements are departed or distributed about the average of number of measured values. That means if we are taking the so many number of measurements for the same instrument for the same value, then the average number, the output is same. Output should be same. This is called precision. Next, sensitivity. Sensitivity. The sensitivity denotes the smallest change in the measured variable to which the instrument responds. It is defined as the ratio of the changes in the output of an instrument to changes in the value of the quantity to be measured. So what is sensitivity? For example, if we are giving an input to an circuit or a system, then what is the change in output? So the instrument will be sensitive only when the smallest change in the measuring variable. If we are changing in small change in the input, then we are getting the change in output also. So it is defined as the ratio of changes in the output of an instrument to changes in the value of quantity to be measured. Mathematically, sensitivity is equals to infinites, infinitesimal change in output divided by infinitesimal change in input, or we can say del Q0 divided by del Qi. The unit of sensitivity are millimeter per microampere, millimeter per ohm, counts per volts, etc. Now deflection factor. It is defined as the reciprocal of sensitivity, or deflection factor is given by 1 by sensitivity. Its units are microampere per millimeter, ohm per millimeter, volts per count, etc. Now resolution. It is the smallest increment of quantity being measured which can be detected with certainty by an instrument. Thus, the resolution means the smallest measurable input change. So, if a non-zero quantity is slowly increased, output reading will not increase until some minimum change in the input takes place. The minimum change which causes the change in the output is called resolution. Resolution in which the smallest or minimum change in input which causes the output, it is called resolution. So for the highly resolution system, for the highly resolution system, the small change in input also cause the change in output. It is called resolution. So these are all about the definitions related to the measurement and instruments. In instrument, it is very important that the instrument should be highly accurate, highly precise, highly resolution, having the high resolution, and then should be very sensitive for getting the exact or accurate output or correct output. So these are all four measurement definitions. Other definition we will see in the next lecture. Thank you.